Hello. In this video, we're going to look at example 2 for review for exam 3. Suppose a certain drug is administered to a patient with the concentration of the drug in the bloodstream t hours later given by the function where 0 is less than t is less than infinity. So k of t is equal to 10t divided by t squared plus 25. On what time interval or intervals is the concentration of the drug increasing? And on what interval or intervals is it decreasing? Now, notice that 0 less than t is less than infinity. This is our domain. So this is where we have to look at. So where are we? Where's the drug concentration increasing for time t? Well, to do that, we need to find the derivative of k of t here. So to find the derivative, k prime of t, we have to use the quotient rule. That would give me the bottom, t squared plus 25, times the derivative of the top, which is 10, minus the top, which is 10t, times the derivative of the bottom, which is 2t. And then all over the bottom squared. Distribute the 10, distribute the 2t, and distribute the negative with it. And so that's going to give you 10t squared plus 250, and then minus 20t squared, all over t squared plus 25, all squared. Now notice that 10t squared minus 20t squared is negative 10t squared. So that's negative 10t squared plus 250, and then all over the t squared plus 25 squared. Good. So that's k prime of t. Now that we know that, we can use it to find where the concentration is increasing. In other words, we need to find the critical numbers here in the domain from 0 to infinity. So we're going to set both the numerator and denominator separately equal to 0. So it's going to give me negative 10t squared plus 250 is equal to 0. And also t squared plus 25 squared is equal to 0. So for the first equation, subtract the 250, divide by negative 10. It's going to give me that t squared is equal to 25. Use the square root property, means t is equal to plus or minus the square root of 25, which means t equals plus or minus 5. And technically, that is the solution, but we don't need the negative because it's not in the domain. So t equals 5 is the critical number there. And over here, t squared plus 25 squared equals 0. Get rid of the square, means t squared plus 25 is equal to 0. Subtract the 25 means t squared equals negative 25. And then use the square root property, means t is equal to plus or minus the square root of 25. But that means that there are no solutions in the real numbers because the square root of a negative number is an imaginary number. And we're only dealing with real numbers here. So 5 is our only critical number. And we do need to understand we begin at 0 and we're going to go to the right forever. So we need to have a number between 0 and 5. Let's just say maybe, I don't know, 1. That'll be a good test point. And any number to the right of 5, maybe 6 or so. And then we're going to plug those into the derivative. Now, plugging 1 into the derivative, frankly, it's going to be positive. Just that's negative. That is negative 10 plus 250 is 240. And that's a positive down here. So it's a positive over positive, which gives us a positive. So it's going to be going up from left to right there. And then if you plug in 6, it will also give you a negative and you'll go down. Now to see that, we would go to the calculator, go to y equals, clear all of this. On y1, I'm going to type in the original function alpha y equals enter, and we have 10t or 10x here over x squared plus 25. On y2, I'm going to type in the derivative, which is negative 10x squared plus 250 over the denominator here is parentheses x squared plus 25 close parentheses squared. Good. Now, if I go to the table and if I just type in these test values, the test values are 1 and 6. Notice that at 1, it's positive. At 6, it's negative. And there we go. Now, if you want to, for the window, do 0. For the x maximum, maybe, I don't know. Then 10 is probably fine. You're not going to see much here. So if I press zoom 0, the blue is the original function. The red is the derivative here. So the original concentration goes up until that point at 5 hours and then starts going down. And there we go. So the question is, where is this increasing? It is increasing on the domain from 0 to 5. Good. And then it's asking, on what time interval is it decreasing? Well, it's decreasing from 5 to infinity. And there we go. Here is example 2 for exam 3 review. Have fun.